Our next unit is in inequalities when you're graphing them, and we're going to be graphing systems of inequalities. These are pretty tricky, but you can do it. First of all, you have to understand inequality, so we're going to be checking a solution. If y is 2, you're going to put 2 here. If x is 1, you're going to put 1 here. And then bring down the rest of the inequality. You're going to simplify, which is going to get you -2 on this side. Is 2 greater than -2? Yes. So number 1 is true. Number 2, I'm going to be setting up the same way. I'm plugging in a -7 and a -3. I need to simplify. -3 minus 3 is -6. Is -7 greater than -6? No. So the answer for number 2 is no. Let's move on to the next one. If you need to hit pause, hit pause. All right, here is where we're going to be graphing. This is what it looks like. The main things to note are right here. When you have a greater than and a less than, it's going to be a dashed. When it's equal to, it's going to be a solid. Everything else is kind of the same. You do have to check for possible solutions to know where to graph, though. If we take a look here, y is by itself, so y is greater than x minus 2. We can graph this just like a regular equation. I'm going to start at -2. I'm going to put 1 over 1, and then I'm going to graph the line. Now, is this going to be dashed or solid? Well, it's a regular greater than sign, not equal to, so it's going to be dashed, which just means that if there's a point on the line, it's not a solution. Okay, we're going to check 0, 0 here. Is 0, 0 a solution? Let's see. If I plug in 0 for y, 0 for x, is 0 greater than -2? Yes, it is. So everything where the solution is above the line, everything above the line is going to be a solution because 0, 0 was a solution. So you have to shade in all of this. All right, let's take a look here. X is less than or equal to -1. So find -1 on the x-axis. This means that it crosses x-axis at -1. It only crosses there. Now this is a solid line because you got an equal to sign. Okay. Is 0 a solution? So if I plug in 0 for x, is it a solution? 0 is less than negative. No, it's not true. So 0 is not a solution. Anything on the other side of the line is going to be a solution. Okay. So hit pause if you need to move on. Kate's plant is 8 inches tall and grows 2 inches each month. We can write this inequality by writing how much it starts with. So it starts at +8, and then it grows 2 inches each month. So I can write 2x here. Now, We're not going to write y equals, we're going to write y is less than or equal to. Now this plant's going to keep growing, so it would make sense to say y is greater than, can it be equal to? Yes, right? Especially, that first month it's equal to. All right. So I'm going to put a dot on the 8. I'm going to go up 2 over 1. Careful with the scale here. The scale already goes by 2's on the y-axis. Because I said it's equal to, I'm going to do a solid line. And then I want to answer the question, which is checking a solution. How many months will our plant be at least, after how many months will our plant be at least 14 inches? So here's 14. Here's the answer. Okay. Number 6. Here is an example of putting it in slope-intercept form first. Okay. This one is pretty easy. All you have to do is subtract the 2x on both sides. We're going to graph the y-intercept. We're going to go down 2 over 1, down 2 over 1, down 2 over 1. And then it's going to be a dashed line because it's not equal to, so I'm going to do a dashed line. Okay, we're just going to check a solution. So let's plug in 0, 0. 0, 0 is right here. If I plug in 0 is greater than -2 times 0 plus 4. 0 is greater than 4. Is that true? No. So we can't shade where the solution that I just checked is. We're going to have to shade it on the other side. Okay, that's it for number 6. You're at the practice section now, so you're going to determine if these are solutions and you're going to be graphing. Ask your group for help.